Hello friends, today we are going to discuss about the first order system in control system and the transfer function of it, how it arrives, and different response analysis. Response means impulse response, step response, ramp response, parabolic response, different kind of response. This is first order system, remember that. So one by one I'll be explaining it. So I have taken here a system where the plant contains 1 by s transfer function, and it is feedbacked. The gain is 1 here and it is negative feedback. Input is rs, output is cs. So we can take it as an example. From this we'll obtain the first order system transfer function. So here, as we know previously, the transfer function will be 1 by s by 1 plus 1 into 1 by s is equal to 1 by s into 1 plus 1 by s is equal to 1 by s into s will be here, s plus 1. S is cancelled, so 1 by s plus 1. So this is the transfer function of the given system. So here you can see that there is only one pole in S plane. So this is first order, but in general case we represent the first order transfer function as 1 by 1 plus st. We multiply this t part because here there can be different kind of systems, so the gain value can be different, and here without 1 there can be anything. So we are multiplying it on t. T is actually the time constant of the system. T is actually the time constant of the system. So now we have found the transfer function of first order system. So now we have to understand different responses, and there is mainly we use in the questions and the theory paper 4 types of input, and through which we get the output is actually called the response of the system. So when we apply impulse input, we get the output. That output is called impulse response. When we input the step function or a step signal, then we get the output, and that output is called step response. This way there is actually 4 type of inputs we generally apply. So these are the 4 types of inputs from which we get the output responses. So first is impulse input. We know the impulse function del t, actually I have taken here as it. Del t is actually looks like this. The step input, we have drawn the step function, similarly ramp and parabolic. So the most important thing you have to understand that what are the Laplace transformation of this. So we know the impulse inputs Laplace transformation is 1. In case of step, it is 1 by s. In case of ramp, it is 1 by s square, and in case of parabolic, it is 1 by s cube. You have to remember this whole chart and never forget this. So first let us discuss about the impulse response. So we know the transfer function of first order system, that is Cs by Rs is equal to 1 by 1 plus St. So now, as the input, that is Rs, that is impulse, so in case of impulse Rs is 1. So from here we can write Cs is equal to Rs will be multiplied 1 by 1 plus St into 1, right? So now to simplify this, we can write it like 1 by T into 1 by, we are taking common T from here, is plus 1 by T. So if we take the inverse Laplace transform, we will find the Ct as 1 by T e to the power minus small t by capital T. We know that. So finally this Ct means the answer in time domain is the impulse response. So always you have to transfer the Laplace domain transfer function in impulse Laplace transform, and you have to find out the time domain response. So that is actual response. So now if we plot this, the response will be like this. So finally it's actually being stable. So from the responses, means the response analysis, we can comment upon the system. So this is actually motive of finding the responses. Similarly we have to do for the other responses. Now unit step response. So now Cs will be 1 by 1 plus St into Rs. So Rs is here 1 by S, right? Exactly. Rs is here 1 by S. So now we have to take the inverse Laplace transform. So to make it easy, we can apply partial fraction method. So we can write it like A by S plus B by 1 plus St. Now if you don't know the formula for A and B, always remember, if there is a function like let's take x into x minus 2. So if we write it like a plus b x minus 2, so how a will become? A will be x, if it's fx, x into fx at x is equal to 0. Similarly if we find b, so b will be x minus 2 into fx at x is equal to 2. This way we can find it. So in this case a will be s into Cs at s is equal to 0. So s into 1 by s into 1 plus st at s is equal to 0. So s is cancelled here, 1 by 1 plus 0 is equal to 1. So it will be 1 by s, it will be 1 by s, and I am doing it here, b will be 1 plus st into 1 by s into 1 plus st at s is equal to minus 1 by t. If we write 1 plus st is equal to 0, s will be minus 1 by t. From here we are putting the value here and we are getting, this will be cancelled out, 1 by minus 1 by t is equal to minus t. So now we have to put this t this t here, and as it is minus t, it will be minus t by 1 plus st. Now we can easily apply the inverse Laplace transform formula. So ct will be, for 1 by s it will be ut, and for t by 1 plus st it will be minus if we do previously t common from the denominator side, so tt will be cancelled and the answer will be e to the power minus t by t. So this is the unit step response. So now if we draw this, if we draw the response, we'll find it like ct t. If we take this as 1, the maximum value of like the value of unit step response, here it will be like this, the ct, it will go on. So finally it is becoming step. So at t time constant, the value, this point will be actually the 63% of the maximum value, means it will be the 63%. That time is called the time constant value. Now generally in case of unit step response, the ct will be 98% at t is equal to 40. You always have to remember this. This often comes in MCQ. So when the output means the response is 98% and the error is about 2%, means it can take it as like we can tolerate it, tolerance value. So this time is called settling time. Settling time, very very important, you have to remember this. This is actually settling time, and t is the time constant. Similarly you can find the parabolic response, and you can take it as homework, parabolic response or parabolic input response. So you can check the answer, the finally the ct will come as, sorry, not the parabolic exam, first ramp response, then parabolic response. Ramp response will become as ct is equal to rt minus t into 1 minus e to the power minus t by capital T. Rt is the ramp input, means this is the inverse Laplace transform of 1 by s square. Check the answer and you will be confident enough. So from the responses we can draw the output plot, and you will see that for unbound input you will get unbound output. So through the response we can comment upon the system and the stability of it. This is the actually utilization of it. So in my next video I will be talking about the second order system, and in that video I will be explaining the rise time, delay time, characteristic equation, natural frequency, sampling damping frequency, and many more important things. So that will be the most important video. I have explained this first order transfer function and system because it will help you to understand easily the second order system. So thank you.